Since the tool changer printhead prototype is finished, it's time to consider the docs and relative mechanisms. This episode is more about imaginations with the current Voron printer. I'll design the details after making a clear choice based on the source I will share later. Hi, welcome to Soul Engineering. I'm David. The tool changer system has a shuttle with multiple tool heads. This setup also needs the same number of the docks for each tool head. The docks provide specific positions to help the shuttle align with the tool heads, making the tool head swapping process more reliable. In this episode, I will discuss more concepts I saw for these docks in various setups. Let's have the first way for the docks, direct mount. As a tool changing at the front side, the docks must also be at the front. This setup has interfered with the door, potentially blocking access to the finished prints. As a result, the dock's optimal position is at the printer frame's top. It makes easy access to the print bed and leaves the print zone intact. However, it still blocks the site, and the tool changing process needs to go up and down when swapping. It could be more efficient. Many solutions on the Voron 2.4 use these methods to achieve the tool changer system, making it a reliable option to stick with. My second concept is a more dynamic approach. It involves an active bar with docks that moves up and down to facilitate tool changing process. The bar is the concept's backbone, dividing my source into two main branches, the mechanisms and the firmware control system. Let's explore each branch in more detail. Modifying the XY gantry front side to accommodate the moving bar is a solution. The front side Z-axis will share the same profiles with the bar. These modifications could potentially hide the docks at the back of the top profile. The steppers might be at the bottom or top to move the bar. However, making the stepper at the bottom only brings them beside the heated bed or passes through the deck with more holes on it. Neither of them is a good solution. So the steppers might be better at the top. Placing them on top will increase the mass of the printer's top. It might differ from the original Voron 2 series purpose of lowering the mass. There is more than just one solution. The floating bar mechanisms could be directly placed on the door frame. The original Voron doors are panels that do not weigh too much. Overall, two steppers, A and B, make up the mass on the printer's rear side. So why not just have two steppers at the front to level the total mass? This custom door frame will include two steppers and belts, similar to the Voron setup, to run the floating bar. In the meantime, the entire mechanism is on the door, which will not bother to access the print bed or block the side when the door is opened. However, this setup is also facing some challenges. How to properly align and secure the door to the frame? How do I ensure the tool heads stay positioned in opening the door? The first answer comes with the hinges and a snap fastener. I previously placed the D-shaped airtight edge strips all around the panels without the doors. At this time, I plan to do the same with the hinges and the snap fastener on the door. These will help to keep the door frame in place and provide stability and airtightness. The two independent steppers will drive the floating bar to align with the leveled XY gantry. The bar might have two optical end stops to engage with the XY gantry to prevent collision. For the second questions, I already showed that I placed the magnets at the front of the tool heads. They should keep the tool heads even when the doors is opened. To deal with the distance the rotating doors creates, I might consider the various lengths of the wires. Both dynamic setups requires a gear ratio to lift the bar, docks, and tool heads. Based on the descriptions, which one is more suitable? Do you have more thoughts on the mechanism? Whether the mechanism is mounted on the printer or door frame, the firmware still needs to operate the extra steppers for the floating bar. According to my research, Klipper doesn't provide an additional axis. The G-Code planner only supports the XYZ axis and the irregular stepper E series. So controlling these steppers will not be easy, like using common G-Code commands like G1, U100, F100 to move the axis U. Instead, Klipper has a functions with the manual stepper. It allows defining end stops and homing on these steppers, making it possible to work with the end stops to achieve the need. A series of G-Code macros will integrate the bars and gantry movements. I'll detail how they work. Once the tool changing process starts, the bars needs to return to the new homing position, which is the gantry position. Then the gantry will send the current tool head back to the dock. After that, the bar will leave a specific offset to release the tool head from the shuttle. And the shuttle will move to the standby positions to prepare for the next docking. Finally, the bar will return to the same height as the gantry to complete the connection. The above is the cycle of changing the tool heads. In these G-Code modules, you will see that the two steppers work as an axis. They need to work simultaneously to perform up and down motions to release and connect the tool heads. Usually the G-Code command will start after the last command is finished. However, in this scenario, the sync parameter is necessary for the first moving commands to let the second stepper move to achieve parallel movement. On the other hand, the second one doesn't need a sync. It waits for the bar motions to finish before processing further commands. Synchronized movement is one of many challenges in these setups. The homing process between the floating bar and the gantry also needs some care. The changing process involves the homing process to find the gantry position. This kind of floating end stop also means no end stops for the bar limits. It poses a risk to have a proper homing process on both. The bar needs to be higher than the entire gantry leveling process, have the least lifting distance, and be the same as the core gantry leveling process, which is basic. After the core gantry leveling, make the custom G-Code commands for the bar first leveling. This is a downward motion to find a home position. Compared to the further homing process during printing, they are basically in upward motions to chase the Z heights of the gantry. The movement can also combine with the slicer settings to make the bar follow the gantry when the Z height changes. These are my thoughts when the firmware is involved in the mechanism. What do you think about the floating bar mechanisms for tool changing? What did I miss in the content? Leave a comment to share your thoughts. If you like thinking and exploring new things in Project From, you may enjoy my other videos. As always, moving forward.